Hi, I'm Richard. I manage the hybrid and electric projects at HamiltonJet, and today I want to show you Aria, which is our hybrid technology demonstrator. EHX is our electro-hybrid drive system, and it includes all the equipment in the drive line, the electric machines, the inverters, the batteries, and the integration of all of that. It also includes the control of all the electric equipment. So in hybrid, that's mode control, alarm and monitoring, and the energy management system. Hybrid comes in lots of different forms. At one end of the scale you have series hybrid, where the vessel will do high speed and electric with diesel generators as a range extender. And at the other end of the scale you have parallel hybrid, where you have diesel engines for your high speed and electric machines for low speed operation. There's really an endless possibility of hybrid configurations that sit between those two examples, and the right configuration depends on the operating profile of each vessel. Aria is a parallel hybrid where we have diesels giving us our high-speed propulsion and electric machines in the same drive line giving us our low-speed operation. HamiltonJet decided we wanted to get into hybrid and electric drive systems. One of the key features are the mode changes between, say, diesel and electric, and there's some complicated stuff happening there, and we want to be able to do that at any speed. To master that, you really have to do it in real life rather than just in simulation. We looked at purchasing a new vessel or building a new vessel versus refitting an existing vessel, and we concluded that refitting a vessel was the fastest way to get a boat on the water. Aria was built in 2007 as a pleasure boat. It's a 15-metre foil-assisted power cat. In early 2020, we purchased Aria and went straight into the hybrid refit. Within the year, we'd purchased and installed the hybrid equipment, fitted our new HDX30 jets, and had the EHX system up and running. On Aria, we have two 530 kilowatt diesel engines, and then a ZF gearbox driving straight through the electric machine onto the jet. With this arrangement we can do diesel mode alone where the electric machine doesn't do anything, or we can stop the diesel engine and we could have 100 kilowatts on the electric machine straight onto the jet, or we can have combinations. We have the diesel running and we're using the electric machine to generate, to take power off the shaft, or we can have it add more power onto the shaft. So we have 530 kilowatts on the diesel plus another 100 kilowatts on the electric machine, giving us just over 600 kilowatts on the jet. We can generate off the shaft because of the difference between the diesel engine's power curve and the jet's impeller power curve. One of the big advantages of using jets in a hybrid system, at most RPMs the jet isn't using all of the available power from the diesel engine. The jet's power curve leaves more power available for generating than a conventional prop would. For electrical propulsion on Aria, we installed 78 kilowatt hours of lithium-ion batteries. We have multiple levels of protection to keep the batteries safe. The battery management system has functions like cell voltage and temperature sensing, and it will shut the batteries down if either of these get too high. The battery room has lots of sensors like temperature, humidity, gas to detect if anything has gone wrong. The batteries get hot when charging or discharging, so we have two air conditioners to keep the space cool. The power electronics on Aria are all Danfoss. That's the electric machines, the inverters, the DC bus, and the control for that equipment. Both the Danfoss system and the battery system take their instructions from AVX, and they pass all their alarms back to our display. To control the system, we use our SDU to select modes. So as well as the automatic mode, we have the chance to manually select the modes. So we're in electric right now. I'm going to force it to go to electric. I'm bringing the RPM up a little. Now if I go to diesel, the system will automatically start the diesels, it'll match the RPM and engage, and then drop away the effort from the electric machines. So that's the transition complete, and now I can bring the RPM up further. And I can do that between any modes at any speeds. Next thing I'm going to do is go to generate, and the system will automatically start taking power off the shaft and putting it back into the batteries. So we're now putting 64 kilowatts back into the batteries. This is actually above the top electric RPM, but I can still select electric and it will just go straight to the maximum RPM for electric. My lever's moved, it'll make that transition, and you can see the engines are now cooling down. If we waited for 2 minutes, they'd cool down and shut down. But I can also go back to diesel, and you'll see we'll go back to the same RPM that the levers are set at. So the RPM comes up, and we're back in diesel. Aria is a superb example of how well an integrated HamiltonJet hybrid system can be. Contact us about a demonstration or your hybrid project.